Solving separable equations. A first-order differential equation of the form dy over dx equals g of x times h of y. So this form is said to be a separable equation. And we can prove, or we can separate it simply by moving the g of x next to the dx and the h of y next to the dy. So to do that, we're just going to simple algebra here. dy 1 over h of y equals g of x dx. And so this here is how a separable equation would be able to separate. Now this is true when h of y is not equal to 0, since h of y is in the denominator here. So that's just a key factor you'll have to remember about that. Alright, so now our next step would be to integrate the equation. And to integrate it, we're going to integrate it on both sides. And here we're going to be adding plus c. Now, technically, c is capable of being here, plus c1, and plus c2 here. But since we don't know the value for the constant c, we're able to assume that we add them together and make it just c. And that just simplifies stuff later on down the line. And this would be an implicit solution. So now, if h of y equals 0, h of y, since we don't know the value of it, we could say is, turn that into h of c, 0. And so y equals c would be a solution for this. Alright, so now let's solve a more practical question, or a more practical example, one that you'll likely get as a question. So now this one, I like to go with the more complex stuff, and for me, doing the sines and cosines and all that is a lot more of a complex avenue. So we're going to do, actually, I'm going to pull it out of that form, and we'll show how to put it into the form. So cosecant y dx plus secant squared x dy equals 0. So now putting it into this form to see if it's separable or not, we would do dy over dx equals, and now we're able to do simple algebra to place the equation such as this. And so you can also write the equation as negative cosecant y times 1 over secant squared x. So it is a separable equation because it fits into that form right there. So now our next step is going to be moving all the y's on one side and all the x's on the other. So when doing this, we would come with negative 1 over cosecant of y, put that in parentheses so it doesn't get confused, dy equals 1 over secant squared x dx. And we're able to do this because cosecant y does not equal 0. And we can prove this over off to the, well, we'll just do below. Cosecant y, we know of one of our laws for the sines and cosine operations, is 1 over sine of y equals cosecant of y. And 1 over sine does not equal 0. Alright, so now since we proved that all of this can be done properly like that, our next step is going to be to integrate each side. Now this is more of the complicated part and where memorization is going to be helping. Because if you remember back from Calculus 1 and 2, we can transform cosecant y and secant squared x into different, more easily manipulated formulas. So 1 over cosecant y, we just went over this, is going to be 1 over negative sine y, and 1 over is going to turn into sine y dy, negative sine y dy. Alright, so now we have our right-hand side. I'm going to put that over here. And 1 over secant squared is able to turn into cosine squared x. So now with cosine squared x, we know that this is also equal to 1 plus cosine 2x over 2. So this is part of the memorization. You're going to have to remember this. And when we integrate it, we're going to integrate the value 1 over 2. We'll be able to separate the fractions, plus cosine squared x over 2 dx. And so now when we integrate it, we know that this is going to be 1/2 x plus 1/2 sine 2x. Remember, cosines turn to sines when we integrate it. 2. And we can get rid of our dx now. And so you can also write it a myriad of ways, such as sine 2 over 4, however you want with that. So now we'll just write it simply though. 1/2 x plus 1/2 sine 2x plus 2. Now we're missing a part, if you can think about it real quick. It's our plus c. So that plus c is very important in case there's anything in the differential equation that we're missing. That's what the plus c is for. Alright, and so now this here is our implicit solution. And now to get an explicit solution, we're going to have to do a little bit of algebra. And to save time, I'm just going to do it in my head. Alright, and so that is going to be, here are explicit solution. So now you're going to need to know how to set these over here to y like this. Because chances are many instructors are going to be asking for the implicit and explicit solutions. Please like and subscribe so I can get more and better videos out. Thank you.